Welcome all students and learners. In this session, we are going to discuss a very important unit that I have taken from the inorganic chemistry. And the name of the chapter I present over here is General Principles and Processes of Isolation of Elements, which is also referred as metallurgy. If you remember, even at the lower class, we have done the metallurgy of aluminium. We had extracted pure aluminium metal from its ore bauxite. So what kind of discussion is going to be involved in this chapter? That how to extract a pure metal from its minerals, which is naturally obtained in the earth crust. Now the question is that why we need metal in the pure form? It's very simple answer, student. The metals are used for various purposes in day-to-day life. For example, if you see ornaments that look so beautiful and attractive are made of valuable metals. Utensils which are present at houses, small parts of machinery, nuts, bolts, pillars, railway tracks, everything. In fact, we cannot imagine our life without metals. So it's a big question how these metals we are getting into what pure form. So here the chemistry or science is the subject which helps us to get all these metals in the pure form from its minerals. So before we proceed, student, first thing we should know that we know that element is categorized into three categories. The very first is metals, then it is non-metals, and it is also metalloids. When you say metal, student, so metals are hard, they are malleable, they are ductile, they are good conductor of heat and electricity, and they have high melting and boiling point. And the property which is opposite of metal is what? Non-metals. And the property is shown by both. Like if any element which is having property of non-metals and metals are referred as what? Metalloids. And they are categorized in the modern periodic table like this. If you'll see, student, group 1 to 2, these elements are called as S block elements, and these all elements are metals. Transition elements which possesses all metallic properties. When I'm saying metallic properties, means they are very hard, they have very high melting and boiling point, they have high tensile strength, and they are very good conductor of heat and electricity. F block elements are also metals, but in case of P block element, you will find the varieties of elements. If you'll see this portion which I have colored with the blue, this portion is what? Metals. This portion which is colored with the green are actually indicating what? Non-metallic property. But between this orange color portion, if you'll see, it is showing property of both metal as well as non-metal. So simply they should be called as what? Metalloids. But conclusion is that if you see this, then maximum number of elements are what? Metals. About 80% of the elements in the nature are what? Metals. Now, how these metals are obtained? Student, it depends upon the reactivity. If you will see, some metals are obtained easily available in the free form. These metals are called as non-reactive like silver, gold and platinum. But most of the metal are reactive in nature, student. So they react with their surrounding component and they form associates. These associates which are naturally obtained are called as minerals. Like in zinc blende, it is obtained in the form of sulfur. In corundum, it is obtained in the form of oxide. And in the rock salt, it is obtained in the form of what? Chlorides. So the conclusion is that, student, metals are obtained in two forms. Associated form or combined form, and that combined form is called as minerals, and some metals are freely available. So on this basis, can we categorize metals into two categories? First, we can say it is reactive metal, and second we can say as what? Less reactive metal. Now let's take some example of reactive metals. If you will see reactive metals like sodium, magnesium, iron, zinc and aluminium, and less reactive metals like silver, gold, platinum, copper and mercury. Now the question is that why we are saying these metals are reactive? Because these metals starts reacting with the component which are present in the surrounding like oxygen, water and carbon dioxide. So when they react with the oxygen, they form oxides. When they react with the water, they form their hydroxides, and when they react with the carbon dioxide, they form their carbonates. But which are less reactive metal, they do not react with these components, and that's why they remain in their free form. The metal which reacts cannot be obtained in the pure form because they are always obtained in the associated forms, which we say as what minerals, and the metal which do not react with these components can be obtained in the free form. So here the question is that which type of the metal is easy to get? Yes, the answer is what? Less reactive metal. But what about more reactive metals? More reactive metal, the extraction part is difficult. So we apply various scientific process which is based upon various principle of the science till we are getting the pure metal. Okay. So isolation of reactive metal is difficult and isolation of less reactive metal is what? Easy. Generally, these associates of the metals which are obtained in the earth crust are called as minerals. But student, there are certain minerals which contain less percentage of impurities and more percentage of metal compounds. These all are referred as what? Ores. Now we should know that, see, when I'm saying ore, so ore is that type of minerals from where metals can be easily extracted, profitably or conveniently extracted. Okay, so these are the different form of the ores. If you will see, some metals are obtained in the form of oxides, some metals are obtained in the form of what? Carbonates, some metals are obtained in the form of sulfides, sulfates, halides, and sometimes silicates and nitrates. These are the various associate of the metal which is obtained because of the reactivity of the metal with the surrounding component. So student, whenever we extract all these metals in the pure form, we take all these minerals which are already present in the earth crust. So do you think, student, these processes of getting pure metal from these ores are easy? No, it is very difficult. So the how science is helping us to get pure metal from these ores? By applying various scientific techniques. So these scientific techniques are referred as what? Metallurgy. So if someone is asking what is metallurgy, we can give a easy definition: the process of extraction, or you can say isolation, of a pure metal. Process of extraction of a pure metal from its ore. Now what are ore? Ores are the naturally obtained mineral from where the metals can be easily extracted. Okay, so the process of extraction of a pure metal from its ore is called as metallurgy. Suppose, student, if I have taken some amount of ore, generally the ore is actually obtained into a stony form. So that stony form is first converted into a powdered form. Once we have converted into the powdered form, means the processes becomes what? Easy. Now this ore is actually a type of mixture, because you can see there are various types of the particle present. Let's say these particles, the bigger particle, are indicating what? Metal compounds in which the metals are present, and the smaller particles are consisting of what? Impurities. So these earthy impurities in science is called as gangue, and this is the metal compounds. Since the ore is obtained in the form of what? Mixture of gangue and the metal compound, so we require only the metal compounds. We do not want this smaller particle. So in order to separate it, we first check the nature of the metal, nature of the impurities, and we apply various scientific suitable processes till we get rid of these impurities and we get what? Pure metal. So when we do metallurgy, student, we separate pure metal and impurities, which is referred as what? Gangue. So this is the pure metal that we have obtained from its ore. So this entire process is called as metallurgy. Metallurgy is the science which provides various techniques by which metals can be extracted conveniently and profitably. So the science is consisting of various terms. Let us understand all these terms one by one. The very first term is what? Student, minerals. So minerals are naturally obtained metal compounds. Now the question is that why metal forms compounds? We had just talked about reactivity of the metal. There are two different types of metal. One is more reactive and one is less or non-reactive. So the metals which are highly reactive have tendency to combine with the surrounding component and form its compounds. So these compounds, if you'll see, which occur in nature along with some rocky impurities, or you can say undesirable substances, we refer as what? Minerals. Okay. Second is what? The every mineral cannot be selected for extraction. Now, same metal can form different types of compounds, but every compounds or every mineral of the metal cannot be extracted or cannot be taken for the extraction purpose. So first we check the content of the mineral, the percentage of the metals and impurities, and after these examination we select some specific minerals. So these specific minerals or selective minerals are called as what? Ore. So how to make the difference between mineral and ore? Ore, we talk about ore is a type of, it is a type of selective minerals. It's a type of selective minerals. So ore is the mineral from which a metal can be extracted commercially or profitably. So the basic difference, student, if you'll see between minerals and the ores is mineral. When we talk about mineral, so mineral may or may not give profitable extraction, but the ore is that type of mineral which always gives profitable extraction and yield higher percentage of the metals. So ore is giving profitable extraction and higher percentage of the metal. It is because it contains appreciable quantity of the metals. For example, if I am taking iron, so iron is one of the example of reactive metals, and iron combines with various surrounding component and present in the different forms in the nature. So if you just check the minerals of the iron, the very first is what? Hematite, and the formula of the hematite is what? Fe2O3. Along with the hematite, the iron is also present in the form of magnetite. The formula of the magnetite is what? Fe3O4. Then limonite, it is the hydrated oxide of iron. Can you see this dot 3H2O is indicating what? Water of crystallization. Iron pyrite, it is the iron sulfide also, and also siderite, which is the carbonate of iron. So there is same metal present in all different types of the minerals. If the iron is present in all different types of associate in the earth crust and it is occur in the different form, but still we examine all these minerals properly and finally we decide extraction of iron is done by what? Hematite. So the reason why hematite is selected out of all those minerals, because it contains maximum amount of iron. If we are carrying out extraction of iron from the hematite, it gives maximum yield of iron, and this process is less expensive, means it is profitable. So such type of minerals which gives profitable extraction of elements from it is referred as what? Ore. But point to be noted, student, if we are taking some amount of hematite, it gives only 70% of the iron. So what about the rest percentage? So these rest percentage are undesirable, unwanted substances, and these unwanted substances are called as gangue, or it is also called as matrix. So gangue and matrix are associated with the ore, which is a selected mineral. So the impurities which are present in the ore are referred as gangue or matrix. So we are using various techniques to remove this matrix or gangue. which we will refer as what? Concentration of ore. So these impurities are, it may be earthy impurities, like it can be sand, maximum percent it contains what? Sand and the particles of the soil. Okay, understood this? Now if you'll see, let's say this is the earth, and this layer of the earth, student, if you'll see, it is consisting of what? Compounds of elements. So if these compounds of the elements are consisting of what? Metals, so these all are collectively referred as what? Minerals. Now these minerals we take out from the earth crust by mining. So about minerals, I can say minerals are naturally occurring substances on the earth crust which are obtained by mining, which contains metal in the free state. When you're talking about free state, means the metal should be what? Less reactive, or noble metals like silver, gold and platinum. And most of the metals are obtained in the combined form. When we are talking about combined form, means they are present in the associated forms, and these associated forms are formed by highly reactive metals. But since we know that all type of the minerals cannot be used for the extraction, so only the minerals which are selected for extraction are referred as what? Ore. Ore, I can say it is the valuable mineral, student, from which the metals can be extracted profitably and conveniently, or commercially. It is what? Less expensive process, and the extraction of the metal is very easy. So we can see the ore is a part of mineral. Can you see, if this entire earth is made up of minerals, then we are selecting some specific minerals from where the metals are extracted. Now these are referred as what? Ores. So ore, when we talk about, it's a type of minerals which contain high percentage of the metal, and from which the metals can be profitably extracted. Now the question is that why ore gives profitable extraction of the metal? Because ore generally contain higher percentage of the metal, less percentage of the impurities, and metals can be easily extracted from this ore. It's very important point, student, that we have to remember. All ores are minerals. Since we are selecting ore from the mineral only, so a very simple term can be used: the ores are selected minerals. All ores are mineral, but all minerals are not ores. It is very important, student. Ore are selected minerals which gives profitable extraction of the metal, but every mineral cannot be taken as what? Ores. So it is very important to know for us what are the different types of minerals obtained. But the question is that why not all substances that contain a metal cannot be used for extraction? It's very simple, student. If you'll see, the metal is extracted from only specific type of minerals. The mineral which gives profitable extraction, convenient and commercially important or less expensive extraction can be chosen for metal extraction, which are called as what? Ores. Let us understand the different types of the minerals and ores of few metals. Let's talk about iron, student. Iron, in the hierarchy, if you will see, the hematite contain what? Maximum percentage of iron, and the formula of this what? Fe2O3. Now student, it's very important to know the formula and these common names, because in the exam they ask in the MCQs and in different form of the question. So when we talk about hematite, so it is one of the mineral of what? Fe2O3. Another form is what? Magnetite. It is Fe3O4. Some more forms like limonite, which is the hydrated iron oxides, iron pyrite, and siderite. The siderite is what? Carbonate of iron. So since the iron is consisting of these associates, these are the general minerals of ions which is obtained from the earth crust. But out of this, the mineral which is selected for the extraction of iron should contain higher percentage of iron, should contain less percentage of impurities, that we refer it as gangue. So that mineral is what? Hematite. That's why all metallurgical industry always take hematite for extraction of iron. So hematite is the selected mineral for the extraction of iron, which is referred as what? Ore. Next is what? Zinc. Zinc is consisting of zinc blende. Zinc blende is ZnS. Zincite. Zincite is zinc oxide and calamine. So these are the three important minerals of zinc, where the major is what? Zinc blende. So the ore of iron is what? Hematite, and the ore of zinc is what? Zinc blende. Some more metals like copper, student, which is very valuable metal. Copper pyrite, if you see, the formula is CuFeS2. There are two metals present over here, but it contains more of copper. That's why it is used for the extraction of copper. Malachite. Malachite is copper carbonate, and this is copper hydroxide. It's a basic, you can say copper hydroxide is basic in nature, so it can be referred as basic copper carbonate. Cuprite is another mineral, if you'll see. Cuprite is what? It's copper 1 oxide. Now, why we are saying it's a copper 1 oxide? If you'll see, the charge of oxygen is what? -2. So the charge will be what? 2 plus. If 2 copper is gaining 2 plus charge, so 1 copper will have charge of +1, and copper 1 plus is called as cuprous. Understood? So it is copper 1 oxide. Copper glans is another mineral which is referred as copper sulfide. So if you see copper sulfide, again it is in the form of copper 1 plus, because sulfur is what? 2 minus, and it will be 2 plus. So 2 plus is given for 2 copper. So 1 copper will get copper 1 plus. Out of these minerals, if you'll see, the selected mineral or ore which contains higher percentage of copper is what? Copper pyrite. And the formula of copper pyrite is CuFeS2. Next metal, very important, aluminium. Bauxite, that we have learned in the lower class also. Can you see, it is Al2O3 dot 2H2O. So it is the hydrated aluminium oxide. This dot 2H2O is called water of crystallization. It is hydrated ore. Cryolite, it's a sodium aluminium fluoride. So it is a fluoride of two metal. One is what? Sodium, and one is what? Aluminium. Next is what? China clay. It is what? Silicate. It's oxide of aluminium and silica. So out of this, if you will see, the major mineral which is taken for extraction is what? Bauxite. So aluminium is extracted from bauxite. Copper is extracted from copper pyrite. Now the next metal is what? Magnesium, student. So magnesium, the mineral that is present is what? Magnesium carbonate, and the magnesium carbonate is called as what? Magnesite. Some more. Dolomite, very important. It is carbonate of magnesium and carbonate of calcium. If you see this formula, then the anionic part, that is carbonate, is same for two different metals. One is what? Magnesium, and one is what? Calcium. So it's a carbonate of magnesium and calcium. Another is what? Epsom salt. So out of this, if you'll see, Epsom salt is what? MgSO4 and .7H2. So what is the water of crystallization? It's 7, student. It is hydrated sulfate of magnesium. Out of this, if you'll see, the mineral which is selected for extraction of magnesium is what? Dolomite. Understood? So these were the important minerals or ores of some metals. So we have to remember all these minerals and ores. So let us discuss the various steps involved in the metallurgical operations. The very first thing, in order to extract pure metal from its mineral, we require a suitable mineral from where the extraction is what? Possible and profitable. So these minerals are referred as what? Ores. So the question is that, can all type of minerals can be said as ore? No. If you'll see, suppose if this is the earth crust and these are the layers of earth. So these layers of the earth is consisting of various types of metal compounds, associates of the metals, and these associates of the metal or metal compounds which are naturally obtained are referred as minerals. Now, if you check the component of these minerals, some minerals contains higher percentage of the metal compounds and less percentage of the gangue particles. So, these type of the minerals are taken for the extraction, and these specific selective minerals are called as what? Ores. The ore which is obtained naturally from the earth crust is basically consisting of mixture, and it is a mixture of two things. One which is present in the higher percentage, and this is present in the higher percentage is referred as what? Metal compounds, and it is consisting of earthy impurities. So these earthy impurities in science is referred as what? Gangue. So the very first step is what? Concentration of the ore. So when we talk about concentration of the ore, student, it involves removal of these impurities and the gangue. So this step is also referred as enrichment of the ore or dressing of the ore. So what we do in this, we separate metal compounds from the impurities or gangue. Since there are various different type of the gangue associated with the metal, so we cannot apply any one or single method to separate all types of the impurities. So what we do, we apply different methods depending upon the ore, that is metal compounds, and the impurities. So the various methods that we are going to use is what? Hydraulic washing. We can also use magnetic separation. We can use froth flotation and leach. So again, if I am saying the various methods is used for concentration of the ore, so this will involve hydraulic washing, magnetic separation, froth flotation, and leaching. So in the next lecture we will learn in detail. Right now I am just saying the name of this. Now concentration is the first and the major step of the metallurgy, in which we are removing all type of the gangue particle. But again there is a difficulty, student. There are certain type of the gangue particle which cannot be removed even after applying all these methods. Some type of the gangue particle which require removal by heating. So the next step which is carried out is the second step, and again this is the main step. It is referred as what? Extraction. So basically in extraction we are heating the ore, but that temperature is below the melting point of the metal compounds, because if you will increase the temperature above the melting point of the metal compound, then the metal compound and the impurities both will get burned. So it is very important to maintain the temperature, and normally the temperature is below the melting point of the compounds. So extraction basically involves compounds of the metal is converted to metal oxides. So it's point to be noted. The metal compounds which is present in the gangue along with the gangue in the mineral is converted to metal oxides. Now the question is that why we are converting it to the metal oxide? Because it is easy to remove metal from its oxide. How? That we will learn in the next lecture. So if the compound is converted to metal oxide, student, we don't want metal oxide, we require what? Metal. So we have to remove this oxide part from the metal. Now we know that removal of oxide from any component to, let's say if we are removing oxide from the metal oxide and converting into the metal. So a basic definition of oxidation, we know that removal of oxygen from any component is referred as what? Reduction. So this step is what? Reduction. So basically when you talk about extraction, extraction is consisting of two things. The very first is compounds is converted to metal oxides, and after converting metal oxides, the oxide part of the metal oxide is removed. This process is called as what? Reduction. Now the question is that how the compounds is converted to metal oxide. It depends upon the type of the ore that we are taking. So we are doing calcination, very familiar term that we have done in the previous classes also. Basically calcination is applied for carbonate type of the ore, and also we are using what? Roasting. Generally roasting is applied for sulfite type of ore. So here there are two methods, student, calcination and roasting. These two methods we convert compound to metal oxides, and we apply various methods of reduction like hydrometallurgy, you can see, pyrometallurgy and electrometallurgy. So hydrometallurgy, pyrometallurgy or electrometallurgy are used for different types of the metal. Why we are using different types of reduction method? It depends upon the reactivity of the metals. In general, we can say for less reactive metal, we use hydrometallurgy. For very high reactive metal, we are using electrometallurgy. And for medium reactivity metal, we are using what? Pyrometallurgy. Once we have removed the volatile particles, or we have converted metal oxide to the metal, so the metal which is obtained, now it is consisting of impurities. So the question is that in the first step we are removing impurities, even in the second step we are removing impurities, then how again it contains impurities? This impurities that is gained by the metal within the processes which takes place. So again the metal that we obtain is in the form of what? Impure metal. So this impure metal should be what? Refined. So third step and the very important step is what? Refining. So when you say refining, it is the purification of crude metal which is obtained after extraction. After refining, since every metal has different reactivity, and separation of impurities from any particular metal demands different methods. So in science there are total 8 different methods have been recommended for refining. Namely, if you will see, one is called distillation. Let's number this. It is one which is called distillation. The second one is called as what? Liquefaction. Third is called as electrolytic refining. Fourth is called as polling. So distillation, liquefaction, electrolytic refining, polling, zone refining, let's say it is a fifth, vapor phase refining, it is sixth method, chromatography, it is what? Seventh method. And there is one more method, student, which is referred as cupellation. Cupellation is nothing but it is a type of liquefaction and distillation related method. You get it? So these are the various methods used. Why we are using different methods? Because the metals demands different methods of refining depending upon its reactivity. After refining, we are getting what? Pure metal. So if you will see, when the ore, when we are extracting pure metal from its ore, so major, there are three steps. The very first is concentration of ore, second is what? Extraction of ore, and the third is what? Refining. So it's a long journey, and after completing this long journey, the ore is converted to what? Pure metal. So this is how the metallurgical operations are carried out. See the next one. When we talk about metallurgical operations, student, so again, if you will see, the major step which involve the ore is first subjected to what? Concentration, second extraction, third refining. Okay, so after doing these three steps, we get what? Pure metal, and after getting pure metal, we can use this metal for the various purposes. So let us understand these steps one by one. So in this list, the very first step is what? Concentration. I told you the concentration. When we talk about concentration of the ore, so concentration required what? Removal of earthy impurities which is naturally associated with the ore along with the metal compound. Concentration of ore is also called as dressing of ore or ore dressing. It is also called as ore benefaction and also called as enrichment of the ore. So there are various names. What is the meaning of this, student? The meaning of concentration of ore is the purpose that we are doing is what? Removal of earthy impurities. Mostly these earthy impurities are soil, silica and other components. How we can define this? Very simple. It is the process of, see the keyword, removal of gangue. Now you know what are gangue. Gangue are what? These are the particles which are impurities associated with the ore naturally. So removal of gangue from the ore is known as concentration of the ore dressing, ore benefaction, or ore enrichment. Understood? Now if you will see, since there are different types of the gangue particle, so the demand of the different method is this, like hydraulic washing, froth flotation, electromagnetic separation, and leaching. So if anyone is asking there are how many types of the concentration method, so it is hydraulic washing, froth flotation, electromagnetic separation, and leaching. Did you get it? See. Now if you will see, let's say this is the ore and it is consisting of, since it is a mixture, for the better understanding, if you'll see, let's say if I have taken as what, some powder form of the ore. So this ore is a type of mixture, student, and this mixture is consisting of two different components. Let's say these particles, the bigger particles, are indicating what, metal compounds. If they are indicating metal compounds, and these particles, the smaller one, is indicating what, undesirable substances, and these undesirable substances are referred as what, gangue. One more time, if you will take ore and if you will convert into the powdered form, so it is a mixture. It is a mixture of two things. The very first thing, if you will see, let's say if it is metal compound, and the second thing, if you will see, it is consisting of what, gangue. So we require only these metal compounds. We require only these metal compounds and we don't require these particles. So we have to subject this powdered form of the ore to a step which is called as what, concentration. So when we talk about concentration, so concentration is nothing but it is the removal of impurities. So after doing concentration, if you will see, you have separated this mixture into two parts. Let's say after doing concentration, you are separating this mixture into two parts. In the very first part, you will find metal compounds, only the particle of the metal compounds, because for extraction of pure metal, we require only the components of the metal. And in the second case, if you will see, we have removed this earthy impurities. So if you will see, this is the metal compound, this is the metal compound, and we have separated gangue from it. So this ore, which is free from gangue and which is obtained after concentration, is referred as concentrated ore. This is referred as concentrated ore. See, so basically concentration is consisting of what, separation techniques, and by using various separation techniques, we have separated metal compound and the earthy impurities. So these earthy impurities are referred as what, gangue, and the metal compound now, which is free from earthy impurities after this step of concentration, is referred as what, concentrated ore. So removal of this earthy impurities from ore through concentration is referred as what, concentrated ore. This method is referred as concentration and this is called as what, concentrated ore. So my simple question is that, student, what is the difference between ore and concentrated ore? See, the ore is consisting of what, mixture of metal compounds and gangue, but concentrated ore is obtained after the process of concentration, which contains only metal compounds. Understood? Basically, if you want to understand this, then let's say I have taken the powdered form of the ore. So this powdered form of the ore is consisting of some particles of the metal compounds and more particles of the gangue. So when we are doing concentration, so we don't require these gangue particles. We require only the metal compounds. So we want to remove these undesirable compounds. So through concentration, we are removing all these compounds till we are getting what, metal compounds. So the ore, if we removed all type of the gangue by applying various types of concentration method, the residual part which is obtained is what, metal compound, and this is referred as concentrated ore. Concentration means what? Removal of the gangue particle from the ore. Since the ore is consisting of the mixture and it is consisting of two types of the particle, metal compounds and ore. So we are using various methods of concentration. So concentration method is what? It is removal of gangue particle or impurities. These are the list of methods that we are using. One is what? Hydraulic washing. Now student, we should know hydraulic washing is used for all types of the ores. Second, magnetic separation. We apply magnetic separation only if any one component of the ore is magnetic in nature. Say for example, if the metal compound is magnetic in nature and the other impurities are non-magnetic in nature. Third method that we can see is for the hydrophobic type of or water hating type of the metal compounds like sulfides. And the fourth, leaching, which is done for what? Less reactive metals. Here if you will see silver and iron, and also with what? Aluminium. So collectively science has described four different methods: flotation, hydraulic washing, magnetic separation and leaching. So let us discuss hydraulic washing. Now we should know that hydraulic washing is used for all type of the ore. So in order to understand hydraulic washing, first we have to discuss what? Principles. Student, we know that the ore is a mixture. So the particles have difference in the densities. And due to the difference in the densities, this is the only point where we can separate. So principle behind this is what? It based on the differences in the gravities. Here I can use the word what? Densities of the ore and the gangue particles. Okay, so gravity separation, if you'll see the arrangement, there is a slope which is consisting of some ups and downs. These ups and downs or the curves are called as what? Grooves. This table or this slope is referred as what? Wilfray's table. You can see there is one arrangement. This is the conical flask like arrangement. This cone is called as what? Hooper. So in this hooper, we just fill the powdered form of the ore, and this powdered form of the ore slowly falls onto this top of the slope. And from other side, we just pass current of water. As this water passes, all lighter particle, can you see these particle which are in the light blue color? These all lighter particle moves along with the flow with the water. But all the heavier particles or the metal compounds which have high densities get stuck into these grooves. Again, in order to understand in more easy way, if you will see, let's say if this is the finally divided powdered form of the ore which is kept onto this slope. So this slope is continuously vibrating. So slowly this particle comes from top toward bottom and then it is taken into a tank like structure where we are passing what? This water. So what happens when we passes the water? If you check this point, when we pass this water, then the ore and the gangue is washed in a stream of water over a vibrating slope table with the grooves. There is a separation take place, student, if you will see, along with the flow of the water. Can you see? All the heavier particle get stuck onto the surface or into the grooves of the Wilfray's table, and all the lighter particles, since the lighter particle which are gangue having less densities can come out along with the flow of the water. So we can separate denser metal compounds with the lighter gangue or particle. Understood this? See, we can also use the method which is called as hydraulic classifier in some cases. If you check this hydraulic classifier, it is a consisting of what? A big tank. Onto the top there is one inlet from where we are subjecting powdered form of the ore. This is also called as what? Hooper. At the base of this tank you will find there is a pipe connected which is consisting of very small opening, and we are passing water through this pipe with the force. So here the addition of the powdered form of the ore in this tank and the flow of the water from this pipe is carried out simultaneously. So if you'll see here, student, the finally divided ore particle are dropped in through the hooper. Can you see this part? We first convert that stony matter of the ore into the powdered form, and we subject that powdered form into this inlet, which we refer as what hooper. And from this inlet, the ore powder gradually falls into the tank. A powerful current of water is introduced through the pipe at the bottom. Again, what I'm saying, there is a pipe which is consisting of what small holes. Through this pipe, we are passing what? Current of water. So as the water rises towards upward, then along with the water, all the lighter gangue particle also rises and it gets collected onto the top. Can you see there is one outlet? From this outlet, we can remove what lighter gangue particle, and the heavier particles settle at the bottom of the stack. That's why we say gangue particles are lighter and are carried away by the current of water at the top. And if you'll see, the heavier ore particles collect at the apex of the cone, which is at the bottom of the reservoir. So this is how all the lighter particle can collect it through this outlet, and all the metal compounds get settles. So this is how we are separating gangue particle and the metal compounds by using gravity separation. Let's see some question which is based upon this module. If you'll see, suppose if I'm asking the process of removing lighter gangue particles by washing in a current of water is called. What should be the answer here? I am producing what? Four different options. One is what? Levitation. One is what? Liquation. One is what? Leaching and cupellation. So this method is what? Levitation. Levitation is related with the term hydraulic classifier, or the method which is based upon the principle of gravity separation. Now see, second question, in gravity separation method is based upon, it's very easy question student, and the option which are given, the very first, preferential washing of ores and gangue particle. Second, differences in densities of the ore particle and impurities. Third, differences in chemical properties of ore particles and impurities. And D, none of the above. So out of these options, which one you feel is correct? Yes, it is based upon differences in densities of ore and impurities. You understood this? Move to the next method of concentration, and the name of this method of concentration is magnetic separation. So when we talk about magnetic separation, as the name suggests student, this is based upon the magnetic nature of either ore particles or the gangue which is associated with it. So the principle which is based upon this is magnetic separation can be applied only if there is a difference in the magnetic properties of the components of the ore. Now we all know that since ore is taken as a mixture, and this mixture is consisting of metal compounds and gangue. So out of these two components, if any one, either metal compounds or ore, is magnetic in nature or attracted towards magnet, then only we can apply this method. If you'll see this arrangement, then in this arrangement, can you see that there is a conveyor belt? This one is called as conveyor belt. It is joining two wheels, student. If you'll see this, this is the wheel and there is another wheel. Out of this two wheel, there is one wheel which is fitted with what? Magnet. So the role of the magnet to the wheel to which it is fitted to attract what? Magnetic particle. So all the magnetic particle are attracted to the magnetic wheel and the non-magnetic particle are thrown away from this wheel. Now in order to understand in the easy way, if you will see this, all the powdered form of the ore. Can you see this conical flask like arrangement? This is called as what? Hooper. So you can say it is acting like what? A collector in which we are subjecting finally powdered form of the ore. So I can say the ground or finely powdered ore is carried on a conveyor belt which passes over an electromagnetic field. So if you'll see this, the particle from this hooper, this finely divided particles slowly falls onto this conveyor belt. This conveyor belt is joining two wheels. One is what? Magnetic in nature. Let's say this wheel is consisting of magnet which is fitted onto its surface, And this one is what non-magnetic in nature. So as the conveyor belt moves, along with the movement of the conveyor belt, the powdered form of the particle is also moving. If you'll see, I have shown two different colors. These two different colors indicating magnetic and non-magnetic nature of the particles. So when this particles reaches to the magnetic field, then the particle which are magnetic in nature or attracted towards magnet will get attracted by the magnetic field. That's why we say electromagnetic wheels of the conveyor attracts only the magnetic particles into a separate heap or separate container. So from here, if you'll see, the magnetic particles are taken into one container and the non-magnetic particles are taken into what? Another container. So it is possible only because there is a difference in the magnetic nature of the particles. Understood? So by using this, we can separate non-magnetic and magnetic particles. So this method was electromagnetic separation and can be applied only if any one component is what? Magnetic in nature. Now let us solve some MCQs on the basis of this. If I am asking a very simple question, magnetic separation is used for increasing concentration of which of the following ore? So if you'll see this, student, the answer is what? Hematite. Now, why we are selecting hematite? Because hematite is magnetic in nature. So for purification or concentration of hematite, we use magnetic separation. Second thing, if you'll see, an ore of tin which contains FeCrO4, it is called as iron chromate. Since it is magnetic in nature, so what should be the appropriate or suitable method? Yes, the method that we are using is what? Magnetic separation. So we can use magnetic separation only if there is one component which is magnetic in nature. Method that we are going to discuss is again dressing of ore method or concentration of ore. Sometimes the ore which contains metal sulfide is concentrated by this method, which is referred as what? Froth flotation. Student, basically this froth flotation method is used for those type of the ore particle which is consisting of metal associate in the form of sulfide. So if there is metal sulfide present in the ore particles, then we use this method which is referred as froth flotation. Here, as the name suggests, we are forming froth or foam of the metal sulfides. For this, let us take some examples. The metal which are present with the sulfur. So if we see this, it is called as zinc blende, ZNS. ZNS is referred as zinc blende, which is the chief ore of zinc metal. Similarly, if you'll see, this is PBS. PBS is referred as galena, which is the ore of lead. And if you'll see this CuFeS2, it is referred as copper pyrite. So, copper pyrite, student, it is ore of what? Copper. Now, if all these minerals, if you'll see, the metals which are present are different, like zinc metal, lead metal, and the copper, but we can see some similarities along with the metal. Since the metals are different, but if you focus on to the non-metallic part, then the non-metallic part is what? Same, student, and this non-metallic part is what? Sulfur. So student, you should know that the metal sulfide are hydrophobic. When I am saying it is hydrophobic, means it is what? Water heating. So if you will add the powdered form of these particles into the water, so they repel water, so they cannot be separated through water. So we add what? Oil. So such type of separation techniques in which we are discussing all this is involved in the froth flotation. So the principle behind froth flotation, if you'll see, is this. Here, the surface of the sulfide ore, if you'll see, the surface of the sulfide ore is preferentially wetted by oil. Now the question is that why to wet surface of sulfide ore we take oil? Because the sulfide ore is water heating and oil attracting. Since the ore is consisting of mixture and it is consisting of particles of sulfide ore and the gangue. So sulfide ore is water hating, but the gangue is water loving. So during this Froth flotation, we use two chemicals. The very first chemical, if you see, it is a mixture of oil and water. So the function of oil to collect sulfide ore from the mixture, and the function of the water to collect gangue particle from the mixture. So if you see this, it's a very important statement. The surface of sulfide ore is preferentially wetted by oil, while that of the gangue is preferentially wetted by what? Water. So can I say there is a difference of the wettability of gangue particle and the oil particle? This is how we do the arrangement when we do Froth flotation process. So let us learn in detail, student. If you will see or understand working of the flotation cell, when I am saying flotation cell, this entire unit which is used for the extraction of gangue particles from the ore is referred as flotation cell. Now if you will see this flotation cell, can you see this black lines? Actually, this is indicating a tank, a big tank. It is referred as Froth flotation tank. To this Froth flotation tank, about 3/4 of this tank, if you'll see, it is consisting of what? Water. And along with water, we take what? Some amount of oil. And now we know that the mixture of water and oil is forming what? Emulsion. So here we are taking emulsion. So this emulsion is what? It is a mixture of water and oil, where the proportion of the oil and the water is adjusted depending upon the type of the sulfide we are taking. From this feed region, you can say it is inlet. We are just adding finely powdered form of the ore. And can you see there is a pipe which is completely inserted, and it is almost just touching the bottom of, or it is just above the bottom of this. Through this pipe we are passing what? Hot and compressed air, and this hot and compressed air comes out from these pores. When this hot and compressed air comes from these pores, it causes vigorous mixing of these particles. So there is a mixing of water, oil and particles of the gangue and the ore. Did you get it? See, the metal sulfide ore which is taken out by oil just get collected onto the surface of this tank, and from here it is skimmed off to another tank which is referred as concentrate launder. Now if you see this, what we do first, the very first thing we do is a suspension of the powdered ore is mixed with water. Let's say if this is the powdered ore, student, we are mixing here. Let's say this is the powdered ore. Now this powdered ore is consisting of what? If you check the component of this, it is consisting of mixture. So when I am saying mixture, student, so it will be consisting of more than one type of the particle. If you will see, let's say these bigger particles are representing what? Compounds of the metals in the form of what? Sulfides. Let's say if it is metal sulfide. So we should know that these metal sulfides are water hating. So the term for water hating we say as what? Hydrophobic. Hydrophobic. Since it is water hating, so the water cannot touch the surface of the metal sulfide, or simply you can say it cannot wetted by what? Water. But student, along with this metal sulfide, since we know that the ore is what? Mixture, so it is also consisting of some particles. Let's say these smaller particles are indicating what? It's a gangue particle. Gangue means what? It is earthy impurities. This gangue is also referred as matrix. Now the property of the gangue particle is opposite of that metal sulfide. So this is referred as hydrophilic. So in this mixture, the metal sulfide is hydrophobic, means it is not get wet by water, or it is water repelling. So it will be water hating and oil loving. But the gangue particle is hydrophilic. When I am saying Hydrophilic means what? It is water attracting, and it will be what? Oil loving. So what we do here is we take two different substances in this mixture. One is referred as collectors and one is referred as what? Froth stabilizer. So collector and froth stabilizer have different functions, students. If you will see collector, so the role of the collector is to enhance the wettability of the ore. See, it enhances wettability of ore or metal components. And froth stabilizes. The function of froth stabilizes is what? It stabilizes foam or froth. So sometimes if they ask the function, what we will say? Collector is mixed to enhance the wettability of the ore. Why it is necessary to enhance the wettability of the ore? Because this ore is hydrophobic in nature. So it will not get wet by water. So there are certain chemicals which are collector. For example, we use pine oil. We can also use fatty acids and we use what? Xanthates. So pine oil, fatty acids and xanthates enhances the wettability of ore, and scientifically they are called as what? Collectors. But you will see the cresols, anilines, these substances are added as what? Froth stabilizer, which stabilizes the froth. After mixing the finely divided powdered form, if you'll see, when this mixture is agitated by passing through hot and compressed air from this inlet, and from the base when this air comes out in the form of bubble, it causes the mixing of all entire components of the mixture. So we say the mineral particle becomes wet by oil. I told you that the metal sulfide is what? Water heating and the oil level. So oil is going to attract all metal sulfide onto its surface, and the gang, since it is water attracting, it will get attracted by water. So if you check the density of the water and oil, student, we know that the oil is less denser as compared to what? Water. So the upper layer of this tank, if you'll see, it will be formed by oil because the oil has less density and the water have higher density. So we can see two different layers. Now there is a rotating paddle agitates the mixture and draws air into it. The role of this, it causes vigorous mixing of this entire mixture, and during this mixing what happens as a result? Froth is formed which carries the mineral particle. When you say mineral particle means what? These all mineral particles are what? Oil attracting and water heating. Since metal sulfide is not wetted by water, so it gets attracted to what? Oil, and the density of the oil is less, so it forms or it gets collected onto the upper surface in the form of froth, and all the gangue particle, if you will see, it just settles at the bottom, and from here tailing or at the bottom it is removed. It is a continuous process, student. From feed we continuously and finally divided powdered of the ore, and from the upper surface continuously we skimmed what? Froth, and this froth is collected into what? A tank, and from here it is dried into what? Sunlight. So this is how the froth production techniques takes place. But the problem arises, student, if more than one metal sulfide is present in the mixture. So for a chemist it is very difficult if more than one sulfide particle is present, and if you are not adding any suitable reagent, so that both the sulfide particle will attach to oil and it will come onto the surface. So if the question is asked, what if two sulfide ores are present? If two sulfide ores are present, student, then we add one chemical which is referred as what? Depressants. So the role of the depressant, at a time it allows only one metal sulfide to go with oil. So depressant will stop one sulfide particle into the tank, and the another sulfide particle will come up with oil. Say for example, if this is the mixture of the ore which is consisting of two metal compound, let's say it is metal compound 1 and it is metal compound 2, and if both metal compound is consisting of what? Sulfide. So what difficulties we will face? If this mixture is taken into the froth flotation tank, student, then the oil is going to attract both the sulfide particle onto its surface. But we don't want to extract both sulfide at one time. So there is no use of the concentration method. So what we do, we add one chemical substance which we referred as what depressant. So this depressant is going to react any one of the sulfide. Now the reactivity of the depressant depends upon the reactivity of the metal which is attached with the ore 1 and ore 2. Let's say ore 1 contains highly reactive metal. So this ore 1 metal will react with the depressant and it will form some complex compound. This complex compound will remain dissolved in the froth flotation tank only. Since ore 2 is not reacting, student, so ore 2 will get free and it will attach to what? Oil droplets, and it will get extracted in the form of what? Froth. See, this is how we are making ore 2 free. So the role of depressant is what? If there is a mixture of more than one metal sulfide in the ore, then only we add depressant. So depressant stops one ore particle into the froth flotation tank, and it allows only one ore particle to go with what? Oil. Did you get it this? See. Say for example, if I am taking lead sulfide. Now if you see this lead sulfide and zinc sulfide, the common non-metallic particle which is present is what? Sulfur. And we know that the property of the sulfur, it is not weighted by water. It is water hating and oil attracting. In this case, if you'll see, the metal which are present over here is what? Different. Like for lead and zinc, if you will see, there are two different type of the metal sulfide as present in the mixture. So we cannot directly subject this mixture to froth flotation tank. So to get rid of one sulfide ore, we are adding one chemical substance which is referred as what? Sodium cyanide. Now here the sodium cyanide acts as what? Depressant. This sodium cyanide, it gets split and it is going to combine with any one of the metal which will have more reactive. So if you compare the reactivity of the lead and zinc which is associated with the sulfide, so student, lead and zinc, if you'll see, so zinc is more reactive as compared to lead. So this sodium cyanide is going to react with what? Zinc, because it is more reactive. So zinc sulfide will get dissolved with the sodium sulfide which act as a depressant and form a soluble complex. This soluble complex is of sodium tetracyanidosincate. It is called. I repeat the name. It is called as sodium 4. It's tetracyanidosincate. And the charge of the zinc over here is what? 2 plus. The charge of cyanide is 1 minus. And the charge of sodium is 1 plus. So this is the soluble complex formed only with one metal sulfide, and that is zinc. Why with the zinc? Because the zinc is more reactive as compared to lead. So this substance sodium cyanide, it depresses, or you can say it acts as depressant, which stops zinc sulfide into the froth flotation tank only. So with oil, only one metal sulfide is free and that will get stick onto the surface of the oil. So with the froth, we will get only lead sulfide. And into the froth flotation tank, we get what? Sulfide of what? Zinc. So this is how we get rid of one metal sulfide ore, by adding depressant if that ore is consisting of more than one sulfide ore. Understood, student? So this is how we do the froth flotation process, and it is applicable for metal sulfide. And if it contains more than one metal sulfide, then we add depressant. Sometimes they ask questions like this. So for example, the ores that are concentrated by flotation method. Suppose if these are the four options, so we have to focus on to that the method which they have described. Now flotation method can be used only for that type of ore where the metal sulfide are water hating and oil loving. So this property is possessed by what? Yes, any guesses? Yes, this is what? Sulfide. So the answer B. Second question they are asking, the froth flotation process is based upon the very first, magnetic properties of the gas. Second, specific gravity of the ore particle. Third, preferential wetting of the ore particles by oil and preferential wetting of gangue particles by the oil. So the answer over here is what? C. It is based upon the preferential wetting of ore particles by oil. One more, if you'll see what they're asking, which of the following is used as a foaming agent in the froth flotation process? Student, as we know that there are two chemicals we are using. One is called as what? Collectors, and one is called as froth stabilizer. So they are talking about froth stabilizer. Now out of these, which chemicals are used as froth stabilizer? So this chemical which is used is what? Pine oil. Understood? Move to the next method of concentration, which is referred as what? Leaching. Like gravity separation, magnetic separation and froth flotation process, we have another method of what? Concentration of ore, and that we refer as leaching. So in case of leaching, student, we use some kind of what? Solvent, and this solvent separates gangue particle from the metal compound which is present in the ore depending upon the difference in their solubilities. It's same like what? Solvent extraction. Now we know that in the solvent extraction what we do, if we have to separate two solid components, then we always use such solvent which allows less solubility of those components along with the different rates of the solvent. So when we talk about leaching, basically the principle which is used behind is this. We are extracting a soluble material. Now this soluble material is actually, it is a metal compound which is present in the particle of the ore. So soluble compound must be what? Ore, and it is extracted from insoluble solid. This insoluble solid is what? It is gas. Understood? When we take powdered form of the ore, then it is consisting of two different type of the particle, and they are having difference in their solubilities. One, the soluble component get dissolves into the leaching agent, and mostly these soluble components are metal compounds which are present in the ore, and the insoluble solid which are present are undesirable substances which are referred as what? Gangue. So mostly metal compound should be soluble and the gangue should be insoluble, and the solvent that we are using, student, is referred as what? Leaching agent. So please remember, soluble materials are metal compounds present in the ore, insoluble materials are gangue particles present in the ore, and the solvent that we are using is referred as what? Leaching agent. Now if you'll see, basically it can be generalized like, suppose if I have taken the finely divided powdered form of the ore, which is consisting of major constituent as metal compounds and some amount of earthy impurities that we refer as what? Gangue particle or matrix. So their solubilities of the solvent that we are using for extraction, which is referred as leaching agent, is for different. If some amount of the leaching agent is added here, so they do not dissolve at room temperature, so we are heating it. So when you will heat, then the compound which get easily dissolved should be of metal compound of the ore. So basically we can say leaching agent dissolves only metal compound, it does not dissolve gangue. It leaves gangue and it leach or it extract metal compound by forming a soluble compound. So can you see the metal compound and the leaching agent gets combined and it forms a soluble compound, and the residual part which remains insoluble in the mixture is what? Impurities or gangue. So this part is what? Soluble. This soluble is a mixture of metal compound and the leaching agent, and this is insoluble substances which are impurities. So we will use the method of filtration. Why we are using filtration? To remove impurities which is insoluble and metal compound and the leaching agent which is what? Soluble. So after filtering we will get the metal compound, and also by heating we can separate metal compound and the leaching agent, and this leaching agent can be reused again for the first purpose. Understood, student? The very first thing, to this mixture we are adding leaching agent. So leaching agent allows solubility of only metal compound by forming a soluble component, and impurities remain in the mixture. So impurities which is being insoluble is separated from the soluble component by the filtration. Now this filtrate, if you'll see, is consisting of metal compound and the leaching agent, which again separated. So the leaching agent we get in the same proportion and can be applied for the first step. Let's take some example. This leaching method of concentration of ore is used in very important metal in the extraction of aluminium. So leaching of alumina from the bauxite. Now the bauxite is the main or major ore of aluminium from where the pure aluminium is what extracted. So this can be done by two processes. In first process we are using what Bayer's, and the second process is what Hall's process. In both the processes, the use of leaching agent is what different. If you'll see, in case of Bayer's process, we are using what caustic soda, and in case of Hall's process, we are using what washing soda. Student, if you'll see this, when we are taking ore or the powdered form of the bauxite. Now we know that the bauxite is what the formula is what it is dihydrated. Why I am saying dihydrated? Because it is consisting of two water molecule with aluminium oxide. So the naturally it is consisting of gangue particle earthy impurities, which is silica or some oxides of what iron. So it is converted into the powdered form, and to this powdered form, student, we are adding hot and concentrated caustic soda. This caustic soda is referred as what? Sodium hydroxide. So when this sodium hydroxide, which is used as a leaching agent, is added into this, then what happens? This sodium hydroxide is going to dissolve only the metal compound of the mixture. It does not dissolve the impurities. So this gangue will remain as what residue, and this metal compound will be extracted by the sodium hydroxide. Now why the reaction take place, student? Because if you'll see, this aluminium oxide is amphoteric in nature. When I am saying amphoteric in nature, means it can react with acid as well as base, and the leaching agent that we have selected is sodium hydroxide, and the nature of the sodium hydroxide is base. So very simple reaction takes place if amphoteric substance is treated with the base. So this amphoteric substance will act as what acid. Now we know that the neutralization reaction, when acid reacts with base, it produces what? Salt and water. So when this bauxite, which is amphoteric, is reacting with the caustic soda, it produces a soluble salt. The name of this soluble salt is referred as what? Sodium meta-aluminate. Now this reaction takes place at a temperature above 150 degrees Celsius. So the sodium meta-aluminate is obtained in the soluble state, and the impurities or the gangue remains what? Insoluble. So the question is that how to separate these impurities and the sodium meta-aluminate. So we can easily separate it through what? Filtration. If you filter it, then the residue which is obtained is of what? Impurities, that is thrown away, and the filtrate we are collecting. To get the solid, that filtrate is cool, and when the filtrate, on cooling this filtrate, student, we are getting crystal of aluminium hydroxide. We are getting crystal of aluminium hydroxide. Since the crystallization process is very slow, so sometimes we are doing what? Seeding reaction. Now what is seeding reaction? We add few crystals of aluminium hydroxide, which just speeds up the crystallization process. So when the aluminium hydroxide is added in the very small quantity, it just speed up the reaction of crystallization of aluminium hydroxide. So we get the crystals of aluminium hydroxide which is insoluble. So this crystal of aluminium hydroxide and the leaching agent sodium hydroxide is again filtered. If you'll filter this, then on into the filtrate you will get what? Sodium hydroxide, and onto the residue you will get what? Aluminium hydroxide. If this residue is heated very strongly, then it releases water from it and it forms alumina. This formula of the alumina is what? Al2O3. So this is how we separate gangue particle from the bauxite by using the leaching agent caustic soda, which is sodium hydroxide. Leaching of alumina from bauxite. An extraction of aluminium can also be done by another method, and the name of this method is Hall's process. Student, before this that we have discussed, that was Bayer's process, and in Bayer's process that was a type of leaching, but the leaching was done by using solvent sodium hydroxide, that we referred as what, caustic soda. In case of Hall's process, only the leaching agent is changed. To get better result, instead of sodium hydroxide in this process, we use what? Washing soda. So let's say if this is the finally powdered form of ore of bauxite, this finally powdered ore of the bauxite is consisting of metal compound in the form of their oxides, that is hydrated aluminium oxide, and along with certain impurities, which impurities is referred as what? Gangue particles. This finely divided powder is mixed with a leaching agent, which we have taken here is what? Sodium carbonate. So the sodium carbonate is the leaching agent used in the Hall's process. So aqueous solution of sodium carbonate, when it is mixed with this, then the sodium carbonate allows only to dissolve aluminium oxide, the impurities remains undissolved. Since it is basic in nature, let us write over here, it is basic in nature, and the nature of aluminium oxide is what? Amphoteric. So if you will see, now when I'm saying amphoteric means what? It can react with acid as well as base. So if it is amphoteric and if it is allowed to react with the base, so the neutralization reaction will take place and it is going to form these products. It forms a salt. The salt formation which has formed in the Bayer's process is the same in the Hall's process. This is sodium metaluminate. Since we are heating this mixture, that's why if you will heat any metal carbonate, generally carbon dioxide gas is evolved, and also there is a formation of what? Water. So these all substances are what, student? These all are what? Soluble. But along with this you will find some earthy impurities which is what? Insoluble. Then the question is that how to separate these earthy impurities which is insoluble with this soluble component. So we are using the method called filtration. So we filter it. If you filter it, then the filtrate contains sodium metaluminate and the residue contains impurities, so that the impurities we can throw it. Now the next step is that this substance that we obtain after the first step is cooled down. Once it is, or on cooling, we are getting crystals of what? Aluminium hydroxide, and if aluminium hydroxide formation takes place very slowly, then externally we just add few crystals of aluminium hydroxide. So it enhances the rate of crystallization, and this process is called as what? Seeding. So seeding is done to increase the rate of crystallization. So aluminium hydroxide precipitate we are getting, it's a gelatinous white color precipitate along with the sodium carbonate. So sodium carbonate is present in the soluble state, and this precipitate, which is a solid, is present in the insoluble state. Then if we will filter it, student, then what will happen? We can separate aluminium hydroxide and sodium carbonate. This sodium carbonate can be again used for the first step, and the aluminium hydroxide which is obtained is heated around 1000 degrees Celsius. So all the moistures in the water just gets evaporated and it forms a residue, and this residue, if you will see, it is what? Al2O3, which is referred as what? Aluminium. So this was the another method of leaching which we had referred as what? Hall's process. Please remember the difference. In Bayer's process, the leaching agent was used as caustic soda, and in the Hall's process, the leaching agent is used as sodium carbonate. So in extraction of aluminium metal, the ore are concentrated by using the method leaching. Similarly, the leaching can be also used for concentration of ore in case of some valuable metal like gold and silver. So let us understand how the leaching method is applicable in case of gold as well as in case of silver. Now we all know that, student, gold and silver have very less reactivity. They are noble metals. So they are mostly present in their native form or non-associated form. So what we do, we take this impure gold metal which is consisting of certain earthy associated impurities, and this we allow to suspend or subject in aqueous solution of the sodium cyanide. Here the aqueous solution of sodium cyanide is acting as complexing agent by providing a very strong ligand. For example, if you see sodium cyanide, so this sodium cyanide breaks, it forms Na plus and Cn minus ion. So here the Cn minus ion is acting as very strong ligand, and this cyanide minus ion combines with the gold and silver ion to form their corresponding cyano complex. But if you see, this gold is consisting of zero oxidation state in the native form, so we need to first oxidize this. For that purpose we are taking oxidizing agent as what? Oxygen, and the source of the oxygen is what? Air. So this oxygen oxidizes the gold metal into the gold ion. The moment when the gold ion forms, it immediately combines with the cyanide and it forms cyano complex of this. The complex which is formed is consisting of the gold in 1 plus oxidation state, and this gold and cyanide, if you see, they are forming coordinate bond. Since one cyanide forms one coordinate bond, so two cyanide forms what? Two coordinate bond. So this 2 is the number of the cyanide as well. Also indicates number of the coordinate bond formed by 2 cyano with the gold ion in 1 plus oxidation state. So this number is referred as coordination number. Since there are 2 cyanide, so this is said as dicyanide gold 1 ion. We are saying ion because there is a negative charge. So this complex which is formed, or you can say the cyano complex of the gold and the silver, is what? Soluble in the aqueous solution. This solution is little basic in nature because of the formation of the hydroxide ion. So this impure gold has converted to soluble complex by using sodium cyanide, which is the leaching agent. So aqueous solution of the sodium cyanide is leaching only gold metal and the impurities remains here. So this soluble compound from the gangue or earthy impurities can be removed by the filtration. Similarly, in the case of silver, this process is referred as desilverization process. So in case of silver, again the silver is present into what? Zero oxidation state. Now it is combining with the aqueous solution of this complex. So if you see this aqueous solution of the complex, it forms Na plus and Cl minus ion. And for the oxidizing agent, we have taken what? Air. So this oxidizes silver into silver 1 plus ion. The moment when the silver 1 plus ion forms, it immediately combines with the cyanide and it forms a soluble complex. This soluble complex is called as dicyanide silver 1 ion, and it is a soluble complex. So here in both the cases, student, if you see, the balancing of the equation and the formulas of the complex is what? Same. So generally we can say that, suppose if this silver and gold are indicated as what? N. So you can say this metal, which is impure metal, is first converted into the powdered form, and this powdered is subjected or suspended into the aqueous solution of the sodium cyanide. So this sodium cyanide is acting as leaching agent. So the role of this leaching agent, it dissolves only the metals and it leaves what? Gangue behind it. So after filtration, you will get a filtrate, and this filtrate contains soluble complexes of the metal. So in this reaction, student, it can be generalized by using this general reaction, and in this, if you will see, these metals are converted into the soluble complex. But the problem is that we don't require this soluble complex, student. We have to extract metal from this soluble complex. So we take this aqueous solution of the soluble complex in one container, and to this, if you will see, if we want to replace this metal, student, if this is the metal and we want to replace this metal from the aqueous solution, so we have to add another metal which should be more reactive to this. So the metal which is used for the desilverization in case of complex of silver, and also in MacArthur process we add zinc metal. So if the powdered zinc metal is added, so since this zinc metal is highly reactive, so the zinc is displacing this metal which is present in the form of complex, which is called as metal displacement reaction. So zinc will come and zinc will form complex with the cyanide. Since the metal which is attached with the cyanide is what silver and the gold, which is less reactive, so cyanide immediately forms complex with the zinc, which is more reactive than the earlier metals. So zinc comes in the complex and this metal comes out because of the metal displacement reaction. So if you'll see, zinc forms a complex tetracyanide-zinc. If you'll see, the charge of zinc is for 2 plus, so it remains in the soluble state and we get metal from here. Now this metal is free from impurities. So this is how we remove silver and gold from their cyano complexes by highly electropositive, highly reactive metal zinc. So this is how we do leaching in case of aluminium, gold and silver. Sometimes students they ask questions like this: why we are using zinc? Because zinc is used for the displacement reaction, because zinc is more reactive as compared to what these metals. Because if you see, the standard reduction potential of the zinc is more negative as compared to gold and silver. So leaching can be a method for the extraction of and concentration of ore of aluminium, silver and gold. The question which is based upon this, if you'll see, they are asking which of the following metal is obtained by leaching its sold with the dilute cyanide solution. So please remember three metal, it can be aluminium, it can be gold and it can be silver. So the option which is given over here is what? Silver. So the answer should be what? Silver. So here we have completed all the concentration methods. This is of above discussions of the metallurgy chapter. You all please try to solve all these questions. The very first is match the following types question and the second is what true and false. So all of you, it's a request, all of you please pause the video, take your time for 2 to 3 minutes and please solve it. I'll get back to you after 2 to 3 minutes, student. Yes, come on, start solving fast. So in match the following, they have asked about hematite. Hematite is the ore of what? Iron metal. So out of this, the formula which is given against the name of it, if you will see, the hematite, there is only one compound which contains what? Iron. So this should be the answer. As the name suggests, it is zinc blend. It should contain zinc. It is the ore of what? Zinc, student. So there is only one formula which contains what? Zinc. So the answer should be what? ZNS. Bauxite, a well-known ore, very famous ore of aluminium. So the bauxite, we know the formula, it is Al2O3 and the correct formula is what? Al2O3.2H2. It's a dihydrogen. Dolomite is the ore of carbonate of magnesium and calcium. It's ore of what? Magnesium. Now let's move to the next question. This is true and false. Here if you will see, they have given all minerals are ore. No, that's false. Ores are those minerals from where the metals can be extracted profitably. So first statement is false. Second, if you'll see, magnetic separation method is employed when any one component, either ore or gangue, are magnetic in nature. Yes, it is true. Depressant sodium cyanide is used in case of ore containing PbS and ZnS. It allows ZnS to come with froth and prevents PbS to come with froth. Yes, it is too strict. For this, for concentration of bauxite ore is digested with the concentrated NaOH in Hall's process. No, this statement is false. It should be Na2CO3 instead of NaOH. When you say desilverization is what? Removal of silver. So in desilverization process, the metal that we are using is what? It should be zinc. So the statement is what? False. Gold and silver are concentrated by using aqueous solution of sodium cyanide. Yes, it is true. So all of you please match the answer. Next move to the next worksheet, that is worksheet number 1.2. Let us try to solve this worksheet 1.2 and it is consisting of fill in the blanks. So go through with these statement properly and try to search appropriate word. Okay. All of you please pause your video and try to solve this. I am giving you 2 to 3 minutes and after this you can check your final answer. Come on, start it now. So if you'll see the very first thing they have asked, collectors enhances dash of mineral and fruit stabilizer dash fruit. So collectors actually enhances non-wettability of mineral and fruit stabilizes fruit. Okay. Second question they have asked is dash is preventing to form froth with bubbles. Student, these substances are called as depressants. Third, sodium cyanide act as dash in preventing ZNS forming the froth as it forms a layer of, so it acts as what? Depressant. And it forms a layer of a complex and this formula of the complex is what it is, Na2, this is ZnCN4. This is called as sodium tetracyanide 2. The fourth is leaching agent used in the Bayer's process and in the Hall's process. So in Bayer's process we use hot and conc caustic soda which is called as sodium hydroxide, and here we use hot and conc sodium carbonate. Fifth, if you see, formula of complex formed by gold and silver with the sodium cyanide. So it can be represented by, this is the metal, it can be gold or silver, it is attached with what? Cyanide. There are two cyanide and there is a negative charge. This is the formula. Dash metal is used for the removal of gold and silver. We use high reactive metal, more electropositive metal, it is called as what? Zinc. Precipitate formed in leaching of bauxite. This answer for this question is aluminium hydroxide. It's a white color precipitate which is formed. 8. Substance used as a frothing agent, collectors and froth stabilizer. So we use pine oil or eucalyptus oil or sometimes kerosene oil as frothing agent. Collectors can be used as fatty acids. Let us write fatty acids over here, fatty acids, and it can also be xanthates. It can also be this froth stabilizer they have asked, so it can be cresol or it is what? Aniline. Concentration method based on difference of specific gravity of ore and metal compound. We use this method, it is referred as gravity separation. 10th, if you'll see, various techniques involve in extraction of pure metal from its ore. This itself is called as metallurgy. So metallurgy. And the 11th one is dash method is used to separate wolframite and cassiterite. The cassiterite is what? It is the tin ore, it is SnO2. So student 1, the wolframite is what? Magnetic in nature, and 1 is what? Non-magnetic in nature. So the method that we can use is what? Magnetic separation. So these are the above type of the question which can be asked on the basis of lecture 1. Thank you.